Hi, this is Nitin Dahad with EE Times, and I'm here at the end of 2 days of ITF World 2025 in Antwerp in Belgium, which is the big Imec event, and I'm talking to one of my fellow correspondents, Pat Brans, who's a freelance correspondent with EE Times Europe. Pat, hello.
Hi, Nitin.
So we've been dividing and conquering here. You've had some very interesting conversations as well, but before we go into those, what's your feeling about this conference and this show?
Okay, well, first of all, it's a great venue, as it's always been. IMEC does a wonderful job of putting together these events. They got a great set of partners, a great set of their own technologists to talk to journalists freely. But for this particular event, if I wanted to describe it in 2 letters, it would be AI.
AI, obviously, right. Yes, and I think that's kind of what everything is these days.
Right.
So I think for me, it's AI, but it's also a lot of conversations I've been having on the show floor and people around here is around how we're going to sustain AI and the compute that's necessary and keeping it power efficient. And
right.
I think that's kind of one of the messages I've been getting.
Right, and I'd say, well, what I've been listening to is that it's not only how are we going to support AI with power efficient computing and lower density, higher density, and more performance, but it's also about how AI is going to support the process of producing better computers.
Yes. Yeah, so that's the other thing.
It's a coupling.
Yeah, there's a presentation from Lam Research this morning, which talked about using AI to produce better processes and things like that. Yeah.
Right, exactly. So computing and storage as well, and integrating storage and computing, not only putting storage memory with the computing processor, but also putting the processor with the memory with as little space left.
Yeah, and I think there has been a lot of talk, not just here, but about how a lot of the heat, the power goes in moving the data around. So trying to get all of that closer is kind of what the research is trying to do, isn't it?
Exactly.
Yeah. And the other big area, I think, and I think I covered this yesterday in EE Times, is the whole healthcare and the technology. And I've already talked about it a lot, so I'm not going to talk again. But
okay.
You can watch my interviews.
Right.
What did you think about the keynotes? I think they're all pretty good, weren't they?
I thought they're fantastic. I like Luke's keynote, the Apple keynote about tailoring silicon, simulating what you're going to do before you do it, because once you do it in silicon, it's very expensive.
Yes.
And by the time you finish doing it, it might be out of date.
Yeah.
Right.
What I felt was quite important about that presentation is just how strategic Apple's move to producing its own custom silicon was, and not just for one product, but adapting the silicon from iPhone to the iPad to the earbuds to the watch and to the Mac, and that whole roadmap and where he showed all the processors that they've developed, the custom silicon and the transition from external to the internal silicon. That whole journey.
Right.
It was just fascinating.
Right. The Google presentation was excellent. It was about using AI to help with the engineering process, with the design and the testing. Okay. Testing is important. You can test, it's easier to test. You can define your test cases using AI. Right.
Let's get to some of the conversations. I think mine are already covered in EE Times. Tell me about some of yours.
So I talked to Greg Bartlett, CTO of Global Foundries.
Okay.
He talked about essential technologies as he presented today as well.
Yeah,
making the difference between increasing performance through reduced size, but by using different technologies in addition to that. And so that was a great presentation, and I also talked to him personally. I talked to Kes Guim, who also presented today, but I had an interview with him yesterday. He was formerly with Intel. He had something like 600 patents to his name in Intel.
Okay. Yeah.
And then he recently formed a company about a year ago, and now it's 170 people. It's called Open Chip. And their thing is to provide hardware for AI. It's a platform, it's a hardware platform that adds certain things like tamper resistance or tamper proofing, so that if you have an AI model running on the hardware, it checks to see if that AI model has changed. So it's actually sort of a PKI for for AI because it goes out and checks with a trusted authority if that AI is the AI you think it is, the model. And that's really good for agentic AI.
Yeah.
Because with agentic AI, you have all sorts of different models floating around. They could be altered. You want to check to see that they're sort of certified.
So was that the same open chip that presented this morning?
Yeah, exactly.
He did a very good presentation.
He did.
But he didn't talk about what they do, which is quite amazing.
He didn't talk about that, but he told me about it, so you can look for that on EE times Europe.
Excellent.
Yeah.
What else? Anything else?
Let's see, I talked to IO. IO's
yes.
got a new way of taking an image and separating the colors while it's coming in and doing that with a waveguide.
Okay.
Right? So separating the images into the spectra that we recognize as human beings, which is important.
Well, we're going to look forward to reading your material in EE times Europe,
Right.
and we'll see you again at the next one, Pat.
Okay, thank you, Nitin.
Thank you.